In this video, we look at solving linear inequalities. We're going to use the same steps as for solving equations, but if you multiply or divide both sides by a negative number, the direction of the inequality symbol flips. Let's look at some practice problems here. The first one is negative 19 is greater than 2v plus 9 minus 6v. So my first step is if I have like terms on the same side of the inequality as one another, I'm going to combine them. So 2v minus 6v, those are like terms, and they're on the same side of the inequality symbol. So I'm going to combine them. So my inequality becomes negative 19 is greater 2v minus 6v would give me negative 4v plus 9. I want to try to solve for v, so I'll subtract 9 from both sides. So negative 19 minus 9 gives me negative 28 is greater than negative 4v. And now at this point, I'm trying to get v by itself, so I'm going to divide both sides by negative 4. This is where this rule comes in. If you multiply or divide both sides by a negative, the direction of the inequality symbol flips. So this symbol is going to flip because I'm dividing by a negative. So those are directly related to one another. If you divide by a negative, you flip your inequality symbol. And so this will become negative 28 over negative 4 would give me a positive 7. The inequality symbol flips to a less than, and then I have v by itself on the right-hand side. So 7 is less than v, or you could write it as v is greater than 7. These are equivalent statements. Notice the wide part of the inequality symbol is towards the v in both of these cases, and the pointy part is towards the 7 in both of these cases. You can check that you have the correct endpoint by plugging that endpoint into your original inequality, and at the endpoint, the two sides should be equal. So like if I did 2 times 7 plus 9 minus 6 times 7, I should get negative 19. So whenever the two sides of the inequality are equal to one another, that's the correct endpoint. So we know 7 was the correct endpoint. We know we got the right direction of our inequality because we divided by a negative, so we had to flip. Let's look at another example. So here I have negative u over 10 is less than or equal to negative 6/5. So notice I have fractions here. So what I want to do is get u by itself. To undo the division by 10, I could multiply both sides by 10. And if I wanted to get rid of the negative in the same step, I could multiply by negative 10, or I can make this a two-step process. So if I did 10 times negative u over 10, that would be less than or equal to 10 times negative 6 over 5. So multiplying both sides by a positive does not flip the direction. But here I have 10 over 10. Those would cancel. Here I have negative 60 over 5. So you can think of that 10 times negative 6 is negative 60 over 5, which would give us negative 12. So this now becomes negative u is less than or equal to negative 12. And here I divide by negative 1 to get rid of that negative. Whenever I divide by a negative, it flips the direction of the inequality. So divide by a negative tells me that this symbol has to flip. And so my final result becomes u is greater than or equal to 12, because negative 12 over negative 1 is positive 12. If you wanted to check your endpoint to make sure that 12 is the correct endpoint, you could plug it in here. You would get negative 12 over 10, and that's equivalent to negative 6 over 5. So that's the correct endpoint, 12 is. And then you just want to make sure you've followed the same steps, the correct steps. You divide by a negative, you flip the inequality. If you want to check that you have the correct direction of your inequality, you could pick a number that's greater than 12 and plug it in. So like if I plugged in 20, for example, then I would get negative 20 over 10 gives me negative 2, which is less than or equal to negative 6/5. So you can always check the direction of your inequality by picking a number that meets that inequality, in this case greater than or equal to 12, and plugging it into your original. If you want to check your endpoint, plug your endpoint into your original and make sure the two sides are equal. Let's look at one word problem, an example of an application. Ahmed is going to rent a truck for one day. There are two companies he can choose from, and they have the following prices. Company A charges $84 and allows unlimited mileage. Company B has an initial fee of $75 and charges an additional 60 cents for every mile driven. So additional would be plus 0.60, and they say use M for the number of miles driven, so 0.60 M. And we want to know for what mileages will Company A charge less than Company B. So less than tells us that we want the less than inequality symbol. So you get your inequality set up, and then you want to solve. So to solve, you follow the same steps as for a regular equation. I'm going to subtract 75 from both sides. 84 minus 75 would give me a negative 9. If you need to check that, you can pull up your calculator, put it in, 84 minus 75. Oh, I'm sorry, that would be a positive 9. I don't know why I said negative. So I have a 9 is less than, here 75 minus 75 canceled. So I just have 9 is less than 0.60 M. I'll divide both sides by 0.60. Now here I'm dividing by a positive, and so the symbol does not flip. So if you divide by a positive number, you do not flip. Do not flip the inequality or the symbol. Okay, so now I just have to do 9 divided by 0.6. 9 divided by 0.6 or 0.60, same thing. So 15. So I'll get M. Let's see, I'll have 15 is less than M. So the question was, for what mileages will company A charge less than company B? And we would say for M greater than 15 miles. For M greater than 15 miles, company A would be charging less. Now notice this is the same as writing M greater than 15. So writing 15 less than M is the same as writing M greater than 15. So remember, for inequalities, you solve them just like an equation. If you multiply or divide by a negative, you flip your inequality symbol. Otherwise, you leave the symbol as is.